This lesson is focusing on an important geometry quantity called volume. We are going to learn what volume is, what kind of units we use to measure volume, and how we can calculate the volumes of a few simple shapes. Volume is a quantity that all 3D objects have. So let's recap. To measure a one-dimensional object, we need a one-dimensional quantity, which we usually call length, and this relates to our perimeter. Then we have a two-dimensional object, like this square, where we can measure it by the two-dimensional quantity that we call area. Okay, so now imagine that we take this two-dimensional square and extend it in the direction that's perpendicular to its surface, creating a 3D object, which we call here a cube. And to measure a three-dimensional object like this, we use the three-dimensional quantity called volume. So volume tells us how much three-dimensional space an object occupies. So just like with area, our units were measured in units, whether that was centimeters, meters, kilometers, it's units squared. Volume is, the common unit for volume is unit cubed. And we'll get to that shortly. So a lot of 3D shapes can be formed by taking a two-dimensional shape and then extending it along the third dimension. So for example, if you start with a rectangle, that's what I've colored in green, and then you extend it along the third dimension, you get a 3D shape called a rectangular prism. So there is a general formula for calculating the volume of basic types of three-dimensional shapes. So all you have to do is find the area of the original two-dimensional shape. So that's our area of our two-dimensional shape, and then multiply it by the distance it was extended by. So this distance here. And we're going to refer to that as the height with a capital H. So let's just label this. So this is our area. And we know for this specific shape, we have our length and we have our width. And we're going to multiply it by this distance here, which we're going to call our height. So when we say area, it means the base shape. So in this case, it's our rectangle. So let's have a look at an example. So we're going to do a rectangular prism to start with. So we know that our formula is volume. So we're going to say V for volume is equal to the area of our base shape, which is colored in green, times H, which is our height. In this case, the area of a rectangle is equal to length times width times H. So in brackets here, that's what A is. A is length times width. So now let's put in our numbers. So the volume is equal to 5 centimeters times 2 centimeters, that's our area, multiplied by our height of 4 centimeters. So our volume is equal to 5 times 2, which is 10, times 4, which is 40. And then centimeters times centimeters would give us centimeters to the power of 3, using our index laws. So we say this as 40 centimeters cubed. So let's do another example where we're not just using a rectangle. So here we have a triangular prism. So my base shape is a triangle, which is colored in green. So let's write out our formula. V equals area times height. Now, our area is going to be of our base shape, which is a triangle. So from our previous video, you should know that the area is half base times height of the triangle. And then we're now going to multiply that by our height in the third dimension. So now let's plug in our numbers. So we have 1/2 times our base, which is 7, times our height of our triangle, which is 6, times the height of our prism, which is 10. So do you see why it's very important to use lowercase and uppercase so you know the difference? Okay, so now we have 1/2 times 7 times 6 times 10. I know that 7 times 6 is 42. Times 10 is 420. So I'm going to go 1/2 times 420, which is the same as saying 420 divided by 2. And you get 210. Now don't forget your units. We're using volume, and it's centimeters times centimeters times centimeters. So it's going to be centimeters cubed. That's all for today, so thank you for watching.